In this video, we are going to discuss about the obscure invention that made the internet possible. The internet feels like magic, a vast invisible web connecting billions across the globe. But this network didn't just appear. It was built piece by people solving problems most never saw. Behind the famous names and celebrated breakthroughs lies a forgotten hero, a simple metal box that unlocked our digital world. In the 1960s, powerful computers were emerging. They were isolated, unable to share data or programs. The challenge, how to make these different machines communicate. Each computer spoke its own language, making direct connection impossible. ARPA, the US Department of Defense's research arm, dreamed of a decentralized network that could survive attack. But first, they needed a universal translator. The solution wasn't to teach every computer every language. Instead, engineers envisioned a middleman. This device would take data, chop it into packets, address them, and send them on their way. It was a radical idea, a piece of hardware dedicated solely to networking. This is the story of that forgotten box and how it quietly changed the world. The dream of a connected planet was about to become reality. The revolution began not with a bang, but with a box, and everything would change. In the mid-1960s, university campuses hummed with computing power. Labs were filled with massive mainframes. They sat isolated from one another, rooms separated, buildings apart. Researchers fed punch cards into these machines. Then they waited hours for results. Collaboration was slow, limited to phone calls and letters. The dream, a network where scientists could share resources instantly, logging into distant computers as if they were local. But mainframes weren't built to communicate. Their operating systems were closed, focused on internal tasks. The solution, offload networking to a separate, specialized device, a gateway that would handle all the protocols and traffic. This breakthrough made the ARPANET possible, and the search began for a company to build this magical box. The future of global communication depended on it. In 1968, ARPA put out a call build the Interface Message Processor, or IMP, in less than a year. Industry giants scoffed at the challenge, but a small firm, Bolt Beranek and Newman, or BBN, accepted. Led by Frank Hart, BBN assembled a team of brilliant, practical engineers. They chose a rugged Honeywell minicomputer as the IMP's base, then set out to invent the hardware, the software from scratch. The IMP guys worked around the clock, fueled by coffee determination. Their task, create a machine whose only job was to talk. As the deadline loomed, pressure mounted, the first IMP had to ship to UCLA. The fate of the ARPANET rested on their shoulders. They weren't famous visionaries, but hands-on builders, and they were about to make history. The IMP was a squat gray steel box. No screen, no keyboard, just blinking lights. But inside it was revolutionary. The IMP connected mainframes to the network, breaking data into small packets. Packet switching. Instead of dedicated circuits, packets traveled independently, hopping from IMP to IMP, finding the best path. This made the network robust and self-healing. At the destination, the IMP reassembled the packets and delivered them to the host computer. The mainframes never spoke directly, only to their local IMPs, which acted as the world's first routers. On August 30th, 1969, the first IMP was delivered to UCLA and connected to a Sigma 7 computer. It worked. Weeks later, a second IMP arrived at Stanford. The stage was set for the first message. The digital revolution was about to begin. On October 29, 1969, in a UCLA lab, Charlie Klein prepared to send the first ARPANET message. He typed L. Stanford confirmed receipt. Then O. Again, success. But after G, the system crashed. The first message ever sent was LO. It wasn't glamorous, but it proved the IMPs worked. The network grew rapidly, with more universities joining and each getting its own IMP. The IMPs became the silent backbone of the early internet. Soon, new applications emerged, like email, invented by Ray Tomlinson at BBN. The network shifted from machine to human communication. Today, the IMPs are gone, replaced by powerful routers, but their core idea, packet switching, remains. The story of the IMP is a reminder: world-changing revolutions often start with small, practical solutions. The unsung heroes at BBN gave us the connected world we know today, and it all began with a humble metal box. If you liked it, tap that like and hit subscribe so you don't miss what's next.